bullet seating depth can be an important variable in rifle precision. You agree with me? I hope so. I think so. And this is especially important and particularly important when we're shooting certain bullet shapes or bullet types. But what is even more important for precision rifles is the consistency of bullet seating depth. And as I've said numerous times, hearkening back to Colonel Plaster and the Ultimate Sniper, it is consistency equals accuracy. Now, having said all that, and I hope you're with me on this, hope you agree with me on this, the next question is, well, how do we measure for this level of precision to ensure that our rounds are consistent? Well, there's a couple of ways to do that. If you're just getting into reloading, kind of taking maybe a basic or general approach to reloading, then certainly using a tool like this, a digital or an analog type of caliper. I had an analog caliper years and years. Of course, I replaced it with this, I guess, a decade or so ago. But this is an essential tool for lots of the reloading that we do. And with this, we can measure what's called cartridge overall length, or sometimes called combined overall length. COAL, C-O-A-L, is that acronym. And that's pretty good. However, that measurement measures, obviously, the entire length of that cartridge, of that particular round. And what's actually more important with these particular precision rifle rounds, this happens to be a 300 PRC destined for my Barrett MRAD rifle. But when we make this sort of measurement, COAL measurement, I got to really open it up for this big thing. You know, we're going to do something like this, and I have 3.679 combined overall length, or cartridge overall length. Now, as I was alluding to, the problem with that is we can have actually fairly consistent bullet seating and yet not have very good consistency in our measures when we're measuring combined overall length, or COAL. And that is because of the inconsistencies on the mepla, right here, that tip of the bullet. We see that with polymer type of tips, and we especially see it in the open tip match types of bullets. So there is a better way, and actually a more meaningful way, to make these measurements, because it really doesn't matter so much on the combined overall length COAL for precision. It does make a difference when you're reloading for pressures and safety and all that good stuff. But for precision, what's even more important is the point of the ogive on that bullet. Where is the ogive on that bullet? And how can we make sure that each of our rounds are consistent in that sort of measurement, that position of the ogive? And so we talked about the shape of the bullet has a tangent ogive, a hybrid ogive, a secant ogive. That describes the shape of the bullet. But when I just use that word ogive, it also takes on another meaning at this point. And what that is, the ogive is that part of the bullet, the first portion of the bullet that will make contact with the rifling, and in particular the lands of the rifling. That is where that bullet will first impact the rifling. Okay? So that measurement is actually much more important to precision compared to the COAL type of measurement. But there's more than one way to measure that. The first way is, again, using this digital caliper. But now we have to change it up a little bit, and it's not quite so basic. You're going to have to buy something like this. Hornady, this happens to be Hornady bullet comparator kit. And what you have here is you have a little, this is the tool itself, and it has an insert in it that this one is particular for the .30 caliber, and it will impact that bullet in approximately the same place that the rifling impacts the bullet. And so we can get what's called a cartridge base to ogive measurement. Cartridge base to ogive measurement using that tool right there. The third way of measuring this, or the second way of measuring the distance to the ogive, is using this tool or similar tools to it. This is made by Accuracy One. I picked it up a number of months ago, and I've been using it tremendously since that time. I talked about it in an earlier video, just kind of talked a little bit about it, started using it at around that time, but I've been using it a lot, and so I feel very, very comfortable using this tool, and I can talk a little bit more meaningfully about it. What this one does is it measures the ogive relative to where this particular round headspaces in the chamber. And this type of round right here, 300 PRC, it's not a belted magnum. It's not considered a magnum round. It headspaces on the shoulder. So what we do is we place this in here. It contacts at the shoulder, and then it will give us the measurement of what we call, or what I call at least, STO, shoulder to ogive. Now, I'm wondering, and actually one of you have already mentioned this as a question, which of these techniques actually provides the best consistency, repeatability of measurements? That's important too, because you have to understand, every tool that we use to measure, and we're trying to measure the consistency of our ammo, well, there are tolerances to the tools themselves. They can measure sometimes to the nearest thousandth, sometimes to the nearest 10,000th, and so on and so forth. So while these all have basically the same measurement tolerance, there are also techniques to how you can measure, how well you can measure. It's very easy to measure with one tool, much more difficult to measure well with another tool, these sorts of things. That's what I'm talking about today. What I'm going to do is I'm going to measure 2 boxes of this Hornady factory ammo, match ammo right here. And what's interesting about this is I've had these couple boxes of ammo for a while. I haven't shot them, luckily. But this one and this one are from the same lot. That's kind of cool. I want to see how 40 rounds of Hornady factory ammo from the same lot, how consistent is this stuff? And do all 3 of these measurement techniques give me the same measure of consistency? I'm a little bit worried about the combined overall length or cartridge overall length. My hypothesis, my guess, is that it will provide us with the largest standard deviation, consistency. In other words, the poorest consistency. I'm not going to be worried about that too much, simply because it's not measuring that distance to ogive, as I already talked about earlier. So I'm going to get busy. I'm going to measure all 40 of these rounds using the Cole method. Then I'm going to add these tools. This is an anvil. This is a separate purchase. Does not come with that kit, but it does help improve the consistency of my measurements. So this is going to be measuring CBTO when I attach it to that digital caliper there. And then I'm going to measure STO, shoulder to ogive, using this tool right here from Accuracy 1. Then we'll come back, look at all those results, discuss all those results. Don't go away. I began by measuring coal, and while doing these measurements, you notice that I also ran a stopwatch to see how long each of these measurement techniques took. So after making 120 measurements, that is 40 with the cartridge overall length, or coal, 40 with the cartridge base to ogive, or CBTO, and another 40 with the shoulder to ogive, or STO measurements. After all of that, we're pretty much ready to look at the results. You'll notice that CBTO took the longest, quite a bit longer than either of the other two methods. Now, while I recorded all of these measurements on paper out here on the bench, I then entered those into Microsoft Excel spreadsheet so I could do some further analysis on them. And the first thing that I did is I looked at some descriptive or summary statistics. And that's what we're looking at right here. What we can see is that the mean and the median for each of those three different measurement techniques is identical. That's good. That means, or that indicates, that we're looking at a normal distribution across these 40 different cases that were measured. You'll also notice that the standard deviation, now this tells us about the consistency of these rounds that we measured, that the consistency based on these measurements varied most using the coal method. Now that's what I had hypothesized, that's what I kind of suspected, and it bore out by going ahead and doing this little experiment, making all these different measurements. It is also interesting that one cartridge in each of the boxes had substantially lower lengths or measurements made. Now that was detected first with that coal method. It was detected again with the CBTO, and it was detected a third time with the STO. And it was the exact same case in all instances. Now that tells us that there's not really something wrong with the measurement technique. It also tells us that there's not something different about the shape of that particular bullet. The only thing it tells us is it confirms that that bullet in those two instances, one in each box, was simply seated deeper into the case than all the others. Focusing on the CBTO and STO measurements, you'll notice, or we can conclude, that they both provide us with the same degree of precision. But here we need to be very clear. What I'm measuring is the consistency of two boxes of factory ammo from the same lot, and this table describes this. It shows us that both CBTO and STO agree quite well. Now, the absolute numbers that are used, that you're looking at in the table here, for instance, the mean of 2.893 versus the mean of 0.799, those are hugely different numbers. Those measurements are made from different points along the same cartridge. Now, to understand this perhaps a little bit better, let's go ahead and take a look at a histogram of the distribution of these different measurements. Now, what we're looking at here is this histogram, and you'll notice that that really tall bar, and that shows us this sort of normal distribution. However, it is skewed the distribution is really skewed to the right. That's where we see the majority or the highest frequency of cases. You'll notice a couple of those far along the left. That's some of those different ones. And in fact, what we're looking at are those two individual cartridges that I already mentioned. So this is good. It tells us that more or less this Hornady match factory ammo, the bullet seating at least is pretty darn consistent. So that's a good thing. And that sort of tells us or answers one of our questions that we talked about earlier. But the more important one now is a question about which of these techniques is the better technique to use. And are they telling us the exact same thing really? Now, to compare two different methods of measurement to see if they really are telling us the same answer or still giving us the same answer, we use what's called the Bland-Altman plot. Now, this technique is used fairly commonly in precision engineering as well as in the medical sciences. So let's say that we have two different ways, two different techniques of measuring blood pressure. One is the standard traditional cuff technique that you've probably endured that. You know, they strap the cuff on you, pump that thing up, and watch that gauge as they release that pressure. That is a tried and true technique for measuring blood pressure. Well, let's say that there's a new technique out there that's purely a digital technique. It's a computerized, automated technique. And before the medical profession is going to adopt this as a good tool to use, they need to know that it's telling us the same thing. And that's where the Bland-Altman plot comes in. Well, we can apply that same technique to assess the measurements of CBTO and STO and ask, is this really telling us the same thing? So what we're looking at now is a Bland-Altman plot for our data. The orange line, roughly going through the center of that plot horizontally, is the mean of our measurements. And when we make these measurements, as we already saw, we can also calculate not just the mean, but the standard deviation. And when we take the standard deviation multiplied by roughly 2, or really 1.96, this is done as it follows a z distribution, and we add that value, standard deviation times 1.96, we add that to the mean. That then gives us that gray bar, horizontal bar, near the top of the plot. If we take that same value, standard deviation times 1.96, and we subtract it from the mean, that gives us the yellow horizontal bar near the bottom of the plot. All of those blue dots that you're seeing in the center between the gray and the yellow bars, that's our actual measurements. And in some cases, the measurement was exactly the same. So if you add all this up, you may not count 40 dots, and that's because they are stacked on one another. What we like to see is this shape, this cluster. Let's say it's a point cloud, all of that data put together. That is really good. That shows good agreement. Now, the 3 points or dots that we're looking at kind of on the left side, those aren't problems. Those aren't problems at all. Those are simply those shorter than normal cases or cartridges that we already talked about. It detects those as well. Now, if we had a difference in measurement techniques, we would see some of those blue dots either above that gray line or below the yellow line. We don't see that. And so 95% confidence tells us that these two measurement techniques are really giving us the exact same answer. Thus, both of these techniques, or either of these techniques, are equally reliable to help us improve the consistency of our hand loads. Now, the fact that STO, shoulder to ogive, measurements using this accuracy 1 gauge, the fact that this is so much faster means to me, that's what I'm going to do. I'm going to use this from now on. And that simply is because it's far more efficient for me to do this. So that wraps up things pretty darn nicely. We know consistency equals accuracy, and we now have two good techniques to measure the consistency of our bullet seating using that very important ogive datum point on the bullet to make that measurement. Questions? Well, if you have some questions, certainly post those into the comments section below. I'll try to get back to you on those as soon as possible. And as always, thank you for watching.